tell me this. How can you tell if an equation is a linear equation? Yes. Okay, so you're thinking what? We're going to actually get to that in a couple sections. But you're right. We can write it y equals mx plus b. And we'll get to that in, I think, 3.3 or 3.4. But how else might you, like, what makes it different than any other equation? I don't know. That's okay. That's all right. Let's put this on the back burner for right now because, yes, Jasir, you're absolutely correct. That's not wrong. But for right now, remember, I'm going to teach you. I know that some of you have seen this before, but I'm going to teach you like you've never seen it before, okay? So one way that we can write is what we call a standard form equation. And the way it looks is just like this, all right? A, B, and C are numbers that can go in there, okay? If you can write it that way, then it's a linear equation. Notice there are no exponents on x or y. There are no other variables in there, okay? A, B, and C can be any number. So maybe 2x plus 3y equals 6. Is that a linear equation? Yes. If you can move the terms around and you can make it look like this, then yes, it is a linear equation. Okay? Let me give you one and you tell me if it's a linear equation or not. Is that a linear equation or not? Ooh, I hear no. I hear yes. Justify your answer. Why? Defend. Okay, I hear there's no x. But what did I tell you about the number in front of x? Well, if it was a 1, it would look like this. And I couldn't just drop it off. It's a 0. You're exactly right. It's a 0. And I could put a 0 there. It's still a line. It's a special line. It only has y. What kind of line is it? Y equals is what we call horizontal line. It goes straight across. You've done this before? X equals is a vertical line. It's just straight up and down. Okay? The takeaway here is if we can write it in the form ax plus by equals c, then yes, we can say it's definitely a linear function, okay? Does anybody know what that c on the end is called? Good guess, but no. This what? Constant. You're exactly right. Good job. This c on the end is called a constant. It's called a constant because it always has the same value. It keeps a constant value. It's always going to be 7. There's no variable causing it to change values, right? It's always going to be 7, so it's what we call a constant. All right, let me give you another one, and you tell me yes or no, linear function. And if yes, I want you to write it in standard form. Y'all ready? Okay. So you're answering 2 questions. Question number 1, is it a linear function? Question number 2 is if it is a linear function, write it in standard form. All right, George says no, it's not a linear function. Does anybody disagree? Jasir disagrees. Why? I could put 3x on the other side. How do I put 3x on the other side? I can do this. Is it a linear function? Yes. Does that make sense to you? Yes, Miss McGee, that makes perfect sense. Yes. It kicked you in your gut. All right, look at this one. Linear function, yes or no? If yes, write it in standard form. I heard no right away, and you're absolutely correct. George is smiling because he said that's an exponent, which means no, it's not linear. That's a good clue if you ever see exponents on the variables that you're not going to be a linear function. Yes or no? Yes or no? Yes or no?
Yes.
Okay, then write it in standard form.
No, because no have it.
That means it's a horizontal.
Good job, George. It is a linear function. It's a horizontal line. How could I write that? It's actually already in standard form, right? Do you see why?
Because it doesn't have it.
You agree or disagree? Sure. I haven't changed the value. Does this make sense? If you cannot move it around and put it in standard form, it is not a linear function. If you can, then yes, it's a linear function. Does that make sense? All right, so I told you we were going to graph, and so we shall. Tell me what a line looks like when you graph it. Straight. Straight up and down could be one way.
Across.
Across. This is x equals something. This is y equals something. Or it could be, okay, that. Or.
Wait, can we do that?
Do what?
Isn't it called like a segment line?
Well, but we're going to keep it going forever. But yeah. But you bring up my next point. How many points do you need to graph a line? 2. You only need 2, right? 2 points to find a line because as long as I have any 2 points on the line, then I can just take out my ruler and connect those 2 points. I dropped my pen in my coffee and I think I messed it up. What? I went to pick it up just now and the end just went way down in my coffee. Okay, so we need, thank you, George. We need 2 points. Keep that in mind as we graph, okay? I'm going to talk a little bit more about a few more things with the line before we actually graph. Let's say I'm on my coordinate plane. Let me put a random line on here. Tell me what you notice about this line. Okay. What does that mean, David? Okay, so David said he saw a y-intercept because it's crossing the y-axis, right? Do we all know that that's what this is called? This is a y-intercept, and that means... That means it's where it crosses the y-axis. Using that same definition there and looking at this line, what do you think this is called? The X intercept. Notice those are 2 points. I only need 2 to define a line. So this is where it crosses. Come on, pen. Now, I'm going to try to get you to a point where, I don't know if you've seen this before or you know this, but I'm going to try to get you to get there on your own. Tell me this. What are the coordinates here of the x-intercept? 2, 0. What are the coordinates of the y-intercept?
0, -3.
What do you notice about these points?
They both got 0.
They both have a 0. You're exactly right. What kind of conclusion can you draw about intercepts?
They're 0.
They have a 0. Okay. If I'm talking about the X intercept, what do you think is true at every X intercept?
The second point will be 0.
You're exactly right. The second part of the coordinate is always 0. What's the second part of the coordinate?
That's
Oh.
the y.
The y, right? This is a crucial thing for you guys to remember, okay? Because it's going to help us in graphing. At every X intercept, all the time, every single time, no matter what it is you're graphing, all X intercepts, y is going to be 0. Every single time. Same thing is true with the y-intercepts. At every single y-intercept ever, x is going to be 0. Every single time. Does that make sense? Does every line have an x-intercept? Why? How would it not? If it's a horizontal, you're exactly right. Every other line will, but if it's a horizontal line, it won't, right? But if you just move it, slope it just even a little bit, eventually it's going to cross that x-axis, right? Patrick, put your phone away, please, unless you don't value it. All right, let's move on to some graphing then. Get to the good stuff. Let's say I gave you this, and I said to graph it using the intercepts. Right? Remember what we know about intercepts and what we know about lines. The first thing, every line is going to have an x-intercept and a y-intercept, right? How many points do I need to graph a line? 2. So if I can find those 2 intercepts, I can just connect them and be done, right? So tell me again what you know about intercepts. What do you know about the x-intercept? Y is going to equal 0. Right? Are we all good on that? And what do we know about the y-intercept? Are we all good on that? So plug them in and find the other half of the point, right? That's what the equation does. The equation tells us if we have an x or a y, we can find the other half. So here, I'm going to keep going back to this same equation. So let me see how I can write this for you in your notes so you'll have it. To graph using intercepts, we're going to plug in 0 for x and solve, and then we will plug in 0 for y and solve. And I'll show you a little shortcut that I use when it's in standard form too in just a second. But we're going to work through it the long way first, so hopefully you understand. I'll give y'all a second to catch up. Some of you are still right. All right, so if I plug in 0 for y, I'm back to this equation, right? Remember what happened on those equations earlier when it just had a y or it just had an x, and we said, oh, well, you could put 0x or 0y for the one that's missing, right? So that's kind of the same thing we're going to do. We're going to say 2x plus 4 times 0 equals 16. Well, 4 times 0 is 0, right? So we could kind of just ignore that part. Sometimes you'll hear me say graph it by cover up. Putting a 0 in.
Oh, you broke it.
What happened?
Dang it.
I think my sweater touched the. That 4 times 0 kind of goes away. Do you see that? So if you just look, Dad, put that phone up. If you just looked at this equation, if you just covered up the 4y part, that's the same thing as putting 0 in for the y. Do you agree? So what we really have is 2x equals 16. So x equals what? Oh, let me show my work here. What do you do to get x by itself? Divide it by 2. So x equals, what's 16 divided by 2, guys? 8. Remember what it is I found, the X intercept. It is crossing the x-axis at 8. What are the coordinates of that point? 8, 0. It's 1 point. I need how many to graph a line? 2. Now I'm going to do the same thing, but I'm going to do it for the other one. Okay. Now I'm going to put 0 in for y. I mean for x, excuse me. 2 times 0 plus 4y equals 16. Again, you could look at this and say, I'm just going to not look at that part, and I'm going to do 4y. This only works in standard form, by the way. 4y equals 16. It is 4, you're exactly right. What'd you do? That's right, divide by 4. What are the coordinates of the y-intercept? 0, 4. Is anybody confused right now?
Wait, where do we get? Is that 0 or 6 up there? We started with. Like we scratched it out.
2 times 0. So now I'm ready to graph, because remember my instructions anyway, George, were what? What's it say? Look beside the problem up there at the very top. What was that? Graph using intercepts. So I found the intercepts first, and now I'm going to graph using those intercepts. So get out your graph paper. Let me write these 2 points down so don't forget them. 8, 0, and 0, 4. Yeah, we'll be graphing for a while. Let's graph it. We needed 2 points. We found 2 points, right? Right?
Right.
They were 8, 0, and 0, 4. Remember, this is x and this is y. And we haven't refreshed much on graphing points. Do we all remember how to graph in the coordinate plane? Okay. We do x first and then we do y. If x is positive, we go which way?
To the right.
If it's negative, we go to the left. And then y, if it's positive, we go. And negative, we go. All right. So I have the point 8, 0. That's my x-intercept. That's where it crosses the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. Anybody confused? Then I have my y-intercept. It's 4, right? It's where it crosses the y-axis. So I go up 4. 1, 2, 3, 4. Now all I have to do is take my straight edge. And y'all have a better straight edge than I do, I'm sure. Connect them. Put your arrows on the end so we know it goes on forever, and there's your line graph. So that is the line. I forgot what our equation was. Where am I? 2x plus 4y equals 16. Yes or no? One more like this. me see. I think I can. Nope. Oh dear, why can't I just delete it? All right. All right, here we go. Let's do one more. You try this one and then we'll come back and do it together. I want you to graph using intercepts, guys. Let me actually move it around a little bit. Graph using... Go ahead, George. Take over.
Good morning, class.
What do you do first?
So first, what you want to do is, so
You're recording.
so when there is a variable with no.
Graph it using the intercepts. Go.
Okay. So, okay. So this is what I'm gonna do. I don't know if it's right, but I'm gonna go plus x.
You're absolutely right. Why are you doing that?
So to get the negative to get the -5 by itself.
That's right. So you're getting it in what form?
In standard form.
That's right. Standard.
Yes, sir. Okay, so x plus y. Stop talking about my plus sign. Equals negative.
Good job. Don't forget that negative on there too.
Yeah,
5.
because the
George
negative.
did a great job. All right, George, pass the pen. To find an intercept, the first intercept. Who's it going to be?
Nah, Ariana, come here. Experience the greatness.
All right, Ariana's going to find our very first intercept. Which intercept are you going to find?
X.
Okay, so if you're going to find X intercept, what are you going to do? How are you going to do that? What happens in every single X intercept? Every single
Oh, I know what to do.
Okay.
0.
Okay. 0 for what?
Y.
There you go. All right. Click the button on the end of the pen. It might just stop working.
X.
Okay, that's all right.
0, and then it'll be
All right, guys, let's focus. You can write with it like a regular pen. It doesn't matter if your hand touches the screen with that pen.
no. It's the X, comma 0.
Okay, so you're plugging 0 in for Y. So plug 0 in that equation for Y for us.
So wait. Can I pass the pen?
Look at your equation. X plus Y equals -5, right? So you're going to plug 0 in for which variable?
X.
Look at you got X0. Which one is 0? X or Y?
Y.
Y. So put a 0 in place of the Y and tell me what X equals when you do that. Keep going.
X.
Do it. So write X plus
0.
plus 0, that's right, equals. So what does X equal?
0. 5, -5.
Y'all stop. Good job. So what are the coordinates of the X-intercept, Ariana? Put it together in your coordinates.
So it'll be -5, 0.
Correct. All right, pass the pen for the Y-intercept.
Baby.
All right, Y-intercept. So this time, what is 0?
0 is X.
Is X, that's correct. All right, Bailey said she's got this. So there's your equation in standard form. she's gonna put, well, don't put X times 0, just put 0, because you're just
Oh.
replacing the X with 0, is what you're doing. That's okay.
Wait, didn't Ariana do the X?
No, she did the Y, there you go.
So then.
We're doing the Y intercept, so. Good job. You don't have to do the Y equals, you can just do the point. All right, so we have two intercepts, an X and a Y. We need to graph them so that we can connect them so that we can have our line. You want to pass the pen to someone for graphing? Someone who hasn't gone yet. All right, Xavier's going to go show us how this graphs on a line. You'll probably have to go to another page there. Oh.
Wait, how you do this?
See the arrows to the right and the left over there on the toolbar?
Wait, hold on, right here?
Go. In fact, if you go back one, I've already got a. George. Okay. You'll need to put your axes on there, yeah. Uh-oh.
She did. She did. I like to. Right here, baby.
She's gonna graph this line given those two intercepts. Remember we had 0, -5, and -5, 0. So we're gonna plot each of those on their corresponding axes. Good job. There's my y-intercept of -5.
And then what's the other point?
0, -5.
Now,
I know that.
She's counting them. There you go.
Oh.
That's okay. It's hard on that screen. On your paper, you can use a little ruler or something to help you connect them.
Alright.
It is hard on that screen. Good job. Good job. Thank you guys. All of you did a wonderful job. No, she did do a good job. All right. Tell me this. I somehow have a feeling we don't have a good handle on this.
I kind of got it.
One more. I keep saying that, but one more for real. I'm gonna give you a second. I want you to do this one. I chose this problem for a particular reason, okay? Several of you, whenever you were coming up, I heard a couple of you try to help out, and you said put the parentheses with the 0, and then somebody did the parentheses with the 0 whenever you didn't need it. But I wanted to show you, I did one that was a little bit different here so you could see when you need the parentheses and what it is we're actually doing, okay? When we're trying to find the x-intercept, we're letting y be what? 0, okay? Notice there's nothing in front of y here. It's just y right by itself, right? So everything stays the same. This is what's changing. And it's changing to what? 0. So I have 2x minus 0 equals 2. So this goes away, right? 0 doesn't have any impact if we're adding or subtracting it. So I just have 2x equals 2.
Oh.
You're exactly right. Then I can divide by 2. And I get x equals 1.
So it's 1, 0, and.
So it's, yes, -2. So it's, 1, 0, right?
Oh,
X is 1 and y is 0. So remember I'm going x, y. Okay? Now let's get the second one. Let's get the y-intercept this time. I'm going to do this a different color so you can see. This time I'm letting x be 0, right? So if you look, you see how there's something hooked with x, that 2? That's why I was doing the parentheses. I was saying this is 2 times x, so it's 2 times 0. Does that make sense? Do you see why we're doing? So you could write it this way also. That's the same thing. That's why I was putting them there if there was a coefficient in front. But regardless, this term cancels out, right? I could have just covered that term up. I'm left with, now be careful here, because I'm not left with y equals 2. No, negative y equals 2. That's exactly right. Good job. I got to get rid of that negative. This is like there being an imaginary -1 in front, right? So to get rid of it, I need to divide by -1. You see why we spent so much time solving equations now? 0, -2. Okay. All right, let's put it on the graph. No more times. No more. A -1, yep. Because there's always an imaginary 1 in front. So if you just have x, that's the same thing as 1 times x, right? But if you have negative x, that's the same thing as -1 times x. You can write them that way. All right, what were the coordinates of my point, of my x-intercept? 1, 0. That means go 1 to the right, here. Yes? And then the y-intercept was 0, -2, so down 2. Does that make sense? Yes, no, maybe so. Y'all got to give me some feedback here. Yes.